Sir, excuse me. Give a minute. I'll
Yeah. Yes, sir. Can we start, sir? Am I audible, sir? Hello? Everything is good. Huh? No problem. Close the door. Close the door. Close it completely. Close it.
Sir, hi sir. Good
Yes,
morning.
sir. Good morning, sir.
Sir, actually, multitask is going on our college, sir, just now because from today they started university exams to our students, sir. Like,
No problem, sir.
so HOD ma'am actually she is there in a meet over there, so she need to start the
Okay.
exams. So she went
10:30.
till exams. No, sir, we'll start directly, no issue. Because ma'am
Okay.
said like you start, sir, maybe it takes some time. So if it is possible, I'll join as soon, or else you just continue with the same like which ma'am informed. So we'll
Okay.
start, sir, now. Okay, no issue, no, sir. No.
Right.
Am I audible, sir? To you? No
Am
issue.
I clearly audible, sir?
Yeah, yes, sir, yes, sir. Just a minute, sir. So, good morning to one and all
Right.
present here. So, here we have a greatest person as a chief guest. So, I'll request Logarshnu to give a brief about our chief guest now.
Yes, sir. A very warm welcome to everyone. About the speaker, Mr. K.K. Vishwanath, with around 40 years' experience working in the quality control and quality assurance and research in various organizations. He has masters in organic chemistry with several original research papers published and referenced in various international journals. Management diploma course from Indian Institute of Management, Ahmedabad. Lead auditor for QMS from BVQI and expert auditor for pharmaceuticals, foods, chemicals, and insecticide industries. He also has Six Sigma belt from Six Sigma Alchemy, Mumbai, qualified as world-class quality assurance and manufacturing excellence course. About his employment profile, currently he is working as Senior General Manager, Quality Systems at Quest Life Science, Chennai. On behalf of Easwari Engineering College, I take utmost pride in welcoming you for this webinar, sir. Welcome, sir.
Thank you so much.
Yes, sir,
And
the session is
wish you all a very warm good morning. Yeah. Thanks for the nice introduction. So, respected Dr. Lavanya Madam, respected Gokul sir, and my dearest and the faculty members and my dearest students. Well, today we are going to have a presentation on quality assurance and risk management pertaining to civil engineering. Well, this topic is something different from your syllabus and all that. You don't have to worry about it, but at the end of the lecture, you will enjoy it and you will feel the importance of this. Now, the title says it is quality assurance and risk management. What is quality? Let's understand what is quality. I've got a very simple definition. Not me. The whole world has got only one small definition for quality. Quality is nothing but to keep your customer happy, to keep your occupant, if you're a civil engineering, to keep your occupant happy, to keep your builder happy, to give him a happy living, to keep him a safe living, to give him the value for the money he has paid. So this is all quality, that's all. How simple is the definition? But then there are a lot of intricacies. It is not that easy. Yes, in order to keep your customer happy, you have to work a lot. And to achieve quality, you need a terrific passion, an attitude for quality, a quality culture. You need to have a quality culture to have this quality. Now, I would like to narrate a very good incident to make you understand. It was something a years back. A US-based company they wanted to manufacture some spares for their automobiles. And they were looking for some competent organizations, which are quality organizations, where they could manufacture the spares. So they just went to an organization and immediately called the management. They had a meeting. And the entrepreneur, the CEO of the company, he said, I want to have a small introduction about your company, your organization chart and all that, your organization, the way, the hierarchy and all that. Then the general manager, he explained about the organization, that we have got a production department, we have got a process control department, we have got an HR department, we have got a quality department, and all that. He explained whatever is there in the organization. He explained everything. Then came the question that how many employees are working in the organization. They said the HR, he said that around 500 to 600 employees are working in the organization. Then I said, where is your quality department? How many people are working in the quality department? The HR general manager said there are around 11 persons, 11 quality. There are 11 persons working in the quality control and quality assurance department. So the American, he said, he once again asked, sorry, beg your pardon, how many people are working for quality? So the HR, once again, he said, sir, 11 people are working in the quality department. This guy was shocked. In an organization where around 600 employees are working, there are only 11 people working for quality. I said, sorry, this is not the organization I'm looking for. He said, thank you very much for visiting your organization, for the care, for the hospitality you all have extended from your side. And that's all. He left the organization. The moral of the incident is, the American could not place orders with this company because when they asked them how many people are working for quality, the reply, what he expected was, sir, everyone is working for quality. Everyone, right from the housekeeping person till the managing director, all are working for quality. But this was not the reply. The reply was, only 11 people are working for quality. How can you achieve quality when this is the kind of the setup in the organization? Now, having said that, how can we achieve this quality? The number one point from the incident, you can straight away, it implies that a total quality involvement is required to achieve quality. Total quality involvement. That is called as TQM. So this is the first thing what we require for quality. Second thing, as I said, we need to have a culture. Again, I would like to narrate a small incident. I happened to meet a professor, a very senior professor in engineering. And I just asked them, sir, I introduced myself and asked them what is, whether you have got any paper in your syllabus on quality. Well, the professor, he thought for a while and said, no, sir, we don't have a special paper in our syllabus for quality, but then we have got a small paragraph in one of the papers. We have got a small paragraph mentioning about the quality. So now, how can we expect a quality culture when we have just one paragraph of quality in the entire syllabus? How do you expect us? How do you expect the country? How do you expect the engineers to be quality competent when there's no awareness? But then I appreciate Easwari Engineering College, your institution, for one thing. So whatever it is, they called me for a presentation, which clearly means they would like to get updated on quality. There is an initiation to know about quality, and they want to have an awareness on quality assurance and quality control and all that. I appreciate. Now, when I said you need a quality culture, an attitude for quality, a burning attitude for quality. Uh, Again, I would like to narrate a small incident before we get into the presentation part of it. Now, see, there is a organization, you must have heard about NASA, the space agency in US. They were making they wanted to manufacture some uh, machine parts for their insulation, for their liquid fuel. It's a very important component. So the entrepreneur and his technical experts, they all went to Japan. Please listen to this incident. They went to Japan and they met the CEO and all the entire team of technical experts. And they expressed the desire that we want to make a spare part which is fitted, which is required in the fuel part, in where the fuel is actually filled up, the liquid oxygen or liquid hydrogen, whatever it is, and that's a very important part. You need a lot of uh, uh, care and a kind of it requires a lot of attention and monitoring in manufacturing the part. The well, the engineers, the experts, and all came. The prototype was given. The drawing was shared with them, and so this is the part we are expecting your company to manufacture for us. It's a very important part. And they also give the specifications. They also give a small tolerance. Normally, whenever there's a manufacturing going on, there is a tolerance given. The tolerance given to the Japanese was out of 10,000 parts, one part can deviate. One machine part can have a small deviation or can be defective. In the 10,000 spares what you manufacture, the 10,000 machine parts what you manufacture, one deviation is permitted. That was all they said. This is the tolerance we can give because it's a very important component. Immediately, the Japanese CEO, he was scratching his head. Then the American CEO, the NASA, the head of the NASA technical department, he said, "What is the problem, sir? You feel that the tolerance is too tight? Is it that out of 10,000 parts, it's very difficult to maintain the tolerance?" He said, "No." He said in Japanese. It was later interpreted to him. He said that basically I'm only wondering. You said no. One defect is allowed. And our Japanese company, we are just thinking how to manufacture the defect. Sorry, we cannot manufacture defects. We are a zero defect company. And that is the attitude. That's what I'm trying to share with you all. You need to be, you need to have that kind of attitude to be a zero defect company. He says, no, I have not learned how to make defects. Now, we just before we get back to the presentation, let us just recall the accidents, the incidents, what happened, the building collapses, the disasters, what happened in the last few months. Even recently in Maharashtra, a 3-storied building collapsed. In Chennai, in Porur, somewhere, a semi-finished building, 11-storied building, semi-finished building got collapsed. In Jammu, a concrete bridge just got washed away. In Neyveli, you all know about the blast, what happened in Vizag, what happened, a crane which was just about to function, it collapsed. Now, why all this is happening? You're using quality materials, you've got very good civil engineers, but why is it happening? Who is answerable to all that? What is lacking? So my presentation is all about that. If you look at it, you have done the construction and left it, that's all. The construction has been done and leave it and go, is it? You need to have a quality assurance. You need to assure the quality in the projects uh, what you deal with. Even before the project starts working, you need to assure the quality. So what is quality assurance? There is something called quality control also. There's a lot of difference between them. In Japanese, quality control is totally eliminated. They don't have quality control at all. Because quality control, it says what went wrong. It's just a postmortem. Has it got any value? In trying to find out why the crane collapsed or why the 11-storied building in Porur, a semi-finished building, collapsed, or recently why a concrete bridge got washed away. So what is the use of investigating and finding out what happened, what went wrong and all that? Therefore, in Japan, the concept of quality control is not there now. They go for quality assurance. Now, what is the difference between quality assurance and quality control? See, all this I'm telling to my dear students. You must understand, I want you, all of you, to be good quality civil engineers, not civil engineers alone. Uh, so coming back to quality assurance, the quality assurance, I told you what is quality control. What went wrong is quality control. What can go wrong is quality assurance. See the difference. And quality assurance, it plans everything even before the project starts. It assures the builder, it assures the project manager. Yes, you forget about it. The building will be constructed as per your plan. Sitting in his room, a quality assurance man can assure with confidence that yes, it will be done. That is quality assurance. That is the concept of quality assurance. Quality assurance is a way of life. There is no department. It's not taught in any books. Now, if we are talking about quality assurance, there's something else called risk management. How both of them are integrated. Now, for a while, I hope you know there is a standard, an international standard. You would have seen even in Larsen and Toubro, which do a lot of constructions, very prestigious company. They have got on the board, it's an ISO 9001, 2015 certified company. Now, what is that? It is an international standard. That is the only one standard in the whole world. This international standard, they clearly advocate that the organization must go on a risk-based thinking. Now, quality assurance is already there, but quality assurance is not sufficient. If a risk evaluation is not done, quality assurance must go a step further to foresee the risk. They should foresee the risk involved in the entire project. And having done that, you evaluate the risk at every stage of the construction process. Identify the risk, quantify the risk, prioritize the risk, mitigate the risk. No, risk is not it is not just, little risk, more risk, and less risk or more risk, nothing of that kind. Risk is now quantified. It is a numerical value, which I will be sharing with you during the presentation. Now, before we get into the presentation, one more thing I just wanted to share with you. But today, there are a lot of quality tools. There are a lot of quality specializations to achieve quality. We have got, I've already discussed about ISO 9001:2015, which is called as the QMS. There is a TQM, Total Quality Management. That is a Total Productive Management. There is a Six Sigma. There is a Six Sigma Master Black Belt course. There is a Six Sigma, a Lean Sigma Master Black Belt course. There is a Theory of Constraints. There is a TPM, Total Productive Management, and there's something called Poka Yoke. These are all, perfect tools for quality assurance. And I will request the top management of your college, of your institution, to expose, to share with you all this, the concept of quality before you pass out. At least there should be an awareness to all the students. They should have an idea about what are all this, but they are really valuable. Today, if you go abroad, more than your MTech or ME or BTech degrees, they want master black belts. They simply ask for, are you a Six Sigma Master Black Belt? Or you a Lean Sigma Master Black Belt? Or a TPM expert? Or do you know something about Poka Yoke? Poka Yoke is a term where even if you want to commit a mistake, you will not commit a mistake. That's the kind of foolproof method it is. And Poka Yoke is now fixed in. Even if you want to commit a mistake, you cannot commit a mistake. That is the kind of assurance this particular methodology gives. Now, having said, let's get into the presentation. I have already defined what is quality. As I said, now the same thing I'm just going to repeat here. It's defined as the degree to which a set of inherent characteristics fulfills the requirement of the owner, builder. It just fulfills the requirements of the owner and builder. Now, what is a degree? It refers to the level of satisfaction. If a customer it depends upon his level of satisfaction. He is very happy. Take it from me, the quality is excellent. If he is okay, so it is good. And if he's not happy, obviously it is a poor quality of construction. You decide what you want. If you want to make your customer delighted, you need to put in your best. No, we were talking about quality assurance. In my introduction, I was just telling you something about quality assurance. What is this quality assurance? The whole world is going behind it. As I said, quality control, I will explain to you what is quality control also. But quality control has gone into the shade now. It has become extinct. We should not even talk about quality control because it does a post-mortem approach. It just talks why the failure happened. Why are we concerned about it? Let us not allow a failure to happen. That is the spirit. Now, what is quality assurance? It gives confidence to the owner, builder, architect. It's a proactive approach, preventive, and it predetermines the failure. Broad spectrum. Quality assurance starts from the building materials suppliers till the finish and handover. It applies the quality monitoring system. We'll discuss about it in the presentation. And the specifications, what they make, it is for the customer base. It is customer centered. Maybe Portland cement is the best in the world, but whether it will fit into it or not, whether it will serve the intended purpose, we don't know. And quality assurance people don't go by standards just like that. They make a sample, they simulate the sample, they simulate, and they see whether it really works or not. The quality assurance also keeps on auditing the entire system to capture the deviations and addresses the gap. There's no use of crying over the spilt milk. If the building collapses, a semi-finished building collapsing or a concrete bridge getting washed away, and you come and you hold an inquiry commission and just start thinking what went wrong and all that, is of no use. So it addresses the cause and not the symptoms. It does a YY analysis. I will tell you something about it. intensity intensifies the controls before the construction is actually completed. Quality assurance people have got no work after the construction is complete. They go away. They go to some other project. They don't have any other work. All the work, everything is planned even before the project is even started. At the planning stage, the quality assurance people, they sit in a room with their experts, and the entire process, the project is thoroughly scanned, and they foresee the risk and ensure that the risk is also addressed. Therefore, to the extent there are no failures at all. You cannot think of failures. That is how Japan works. Now, the quality assurance, they validates the materials, processes, equipments, methods, and procedures. It insists on representative sampling. Suppose you get a material of, say, bricks or something like that. You get a big lot of bricks. Quality assurance says that you don't go by the top one. Probably they say that, okay, finally, what happens? The top layer of bricks, what has come for construction, could be very nice. But in between, they could have concealed all substandard quality of bricks. We don't know. You may just go by the top layer. So what quality assurance? Quality assurance, as I said, they foresee the risk. They don't believe anyone. So they will always think what can go wrong. So there is a feeling that if there is on the top, there are a good layer of bricks, and in between, in the basement of the lorry, there are all substandard bricks. The building could collapse. The building may not be as strong as you planned for it. And it also specifies the date of completion of construction and date of expiry. When we make a medicine in pharmaceuticals, they say they give the date of manufacturing, they also give a date of expiry. Why can't we do that? Can we give a date of expiry after which the occupant should vacate the building? That is the kind of spirit I expect from our next generation civil engineers. Now coming to quality control, as I said, they will just test the materials, they'll give the results and go away. The quality control, as you can see, Japan has eliminated QC approach several years back. The routine analysis of building construction materials, they do only the routine analysis, checks whether it is as per the specifications or not. They maintain records. It's a very reactive approach. On the other hand, the quality assurance was having a proactive approach. Quality control has got a reactive approach. It addresses the cause. Quality assurance was addressing the cause. Quality control addresses the symptoms. It's too late. QC persons will only report what went wrong. It reports the construction results, not bothered about the completion of the project. They are not bothered about it. They're not bothered. They don't foresee the risk. They'll just construct it. On that day, if the results are okay, that's all. They don't foresee any risk or anything. That is not the job. We'll test the water. If you say you test the water before construction, they will test it and give the results. If it fails, they'll say, sorry, sir, I can't do anything in the field. It has failed. So you replace it with some other water. But where do you go for other water? We'll test the iron quality used for construction of quality. We'll test if there is iron, the iron quality, the strength and all, and then they'll give you. And between what happens is the supplier will give a good iron quality, and the next lot may not be of that standard. And that is how big foundations all collapse. Now we test the quality of concrete. They will say, I have used this particular standard, but who knows whether that standard will work, will serve the intended purpose or not. Now, coming to this quality management system, which is called as QMS, I was talking about ISO 9001 2015, which many companies, the world-class construction companies like Hindustan Construction and Larsen & Toubro, they're all certified to ISO 9001 2015. What does the standard say? The standard clearly says you need to have quality assurance. That is right. That is fine. But you also need to have a risk-based thinking. A risk assessment need to be done. Now, quality assurance assesses the risk from start to finish. As I said, sitting in a room with their experts, they do a brainstorming. From start to finish, raw building materials, to the final construction, the criticality in the construction process, the probable occurrence of various failures, the current detection levels, they are all worked out with the entire team to evaluate what can go wrong. That is the philosophy. Quality assurance will simply keep talking about this, what can go wrong in every step of the construction. And they keep on taking the preventive measures. They keep on taking no corrective measures. It's only preventive measures. And who can do it? It is not written in any books. You will not find quality assurance in any of the civil engineering, in any of your syllabus or in any of your books or in any of your standards. It is just an experience. All people sit together, all experts sit together, right from the workman, construction workman, to the top man. They sit together, they do a brainstorming that what can go wrong, what can go wrong in the foundation, what can go wrong, and the entire process. Not now, even after several years later. So quality assurance is a greater accountability and assuring that the required building would be constructed as per the customer requirement and handed over in time. Quality assurance need to be highly proactive and do a thorough risk analysis with the help of uh, and they should, how to do that. We are going to uh, understand how the risk is evaluated. What is the concept of quality assurance? The concept of quality assurance, as I have already explained to you, it is preventive mistakes. There's no use of crying after the building collapses. They don't permit that. Everything is done even before the project is commenced. So preventing mistakes and defects, forcing the risk involved in construction operations. Quality in a construction process, how? The planned and systematic activities implemented in a quality system so that quality requirements for the construction and its completion will be fulfilled. That is their objective. They will ensure that all the quality requirements for the construction and its completion are fulfilled. QA services primarily used by owners and developers. Now, the owners are using QA services to evaluate how a contractor is achieving specified conditions and design standards. QA is either measured before a project begins or while a building is undergoing construction. QA has no role after the construction is complete. Quality assurance starts its work right from planning, sourcing of building raw materials till the delivery of the finished product or the delivery of the constructed house to the customer. A risk assessment is done at all stages. The quality assurance, they have got a small device. It's called as a quality monitoring system. What they do is they periodically monitor during the construction process. They keep monitoring and the recording in this kind of table. It says about the inspection. If you look at it, the inspection point, the purpose of inspection, what are the parameters to be inspected and checked by whom, at what frequency, and what is the method of inspection, and what are the specifications as per the parameters, as per the plan, and most important is action upon deviation. If something is going wrong, something is not fitting in, so how do you act on it? What is your action? And finally, you decide whether that particular stage of the process is a control point or a critical control point. So this table, this kind of monitoring is done at every stage. You can imagine, just for an example, ceiling construction is the inspection point. The purpose of inspection is ensure proper ceiling is constructed. The parameters of the concrete mix setting checked by so and so. The person who checks, his name is also there, so that when there is a problem, you'll be able to identify who is the person who certified it, who analyzed it, who okayed it, and at what frequency is also given. He says at the beginning and during the construction process, this is the frequency. You need to test the concrete mix at the beginning, even before it is transferred to the building, it is tested. Now, how to test is also given. Make a mold and test its hardness, whatever it is. I'm giving an example. And the specifications are also given. What kind of cement is to be used, what kind of iron bar have to be used, what should be the quality, what should be the carbon content, what should be the brittle hardness, what should be the tensile strength. Everything is given. An action upon deviation, in case there is a problem, you don't have to call. You don't have to call the your managing director or your senior manager as to how to overcome the problem. Everything is mentioned in this table. Now, what is the key to quality assurance? Be proactive and conduct a risk evaluation through failure mode effect. Now, we were talking about how to evaluate the risk. There's a beautiful table called FMEA. The whole world does it. In fact, for the Mangalyaan, where our spacecraft landed in Mars, unmanned spacecraft, when it successfully landed on Mars, the director of the space agency came out and said, we were very successful because we did a lot of failure mode effect analysis. So to that extent, it has got a very, very high significance. Why not you all learn? I have even, during my discussion with Professor Gokul sir, I told him that we'll conduct a workshop in your institution. And we actually do a workshop with failure mode effect analysis for any construction work, for any project work. And you will see it will be done with your help. You all will be there, and we'll conduct a workshop which will be very useful for you. And you can do the same thing when you're employed elsewhere. QA always works on what can go wrong. I've already told about it. The risk is evaluated at all steps, starting from the design to finish. Even before the starting of the project, the risk is identified based on severity and one minute. So we also give a number to the risk. Why? Because we need to have a number to prioritize. Say, for example, the risk. What is the risk? Risk is a multiplication of severity multiplied by the detection control and multiplied by the occurrences. So severity into detection controls into the occurrences will give the risk priority number. Now, the highest, the risk priority number, which has got a higher value, need to be attacked first. They need to be taken on priority. And then you have to keep on doing the failure mode effect analysis till the RPN number comes down. We'll look at it as we go through the presentation. And it will be done only by the experience. It will be done only by you all, by your experts, and you are the best people. Another word I wanted to say before we go to the next slide. The Indian civil engineers are the best in the world. I need to tell you this. Throughout the world, the best civil engineers are from India. And they like Indian civil engineers. Why? Because they're highly site-oriented. And they stand in the site and perform all the supervision and monitoring. And third thing is they've got a lot of dedication. They know the job. And the most important is the education. We have got an excellent syllabus. We have got an excellent education system. And we have got very good professors to update you on the civil engineering procedures, on the civil engineering techniques, and the civil engineering methodologies. Now, I was talking about the disasters. Let us also have a look at this. 10 of the most shocking construction failures in the world. The root cause was determined after the damage was done. No use. These causes, what you're going to see now, what you're seeing on the presentation, they could have been captured during the risk analysis. But risk analysis was not done. For example, in Quebec City Bridge in 1907, it collapsed because the main cantilever collapsed. Chicago Crib Fire, January 1909, it collapsed because why? Because a temporary dormitory crib constructed of wood and brick caught fire. St. Francis Dam, March 1928, collapsed. Cause defective foundations, not the dam design, were to blame for the collapse. Banqiao, it's a reservoir dam in 1975. It collapsed, caused failure of the dam's sluice gate, typhoon, NINA, wrongly designed without proper validation. My goodness. Hurricane Katrina, you all know about it. We all know about it. New Orleans levee system, August 2005, caused it collapsed because installed at a depth of 17 feet instead of the initially suggested depth of 31 feet to 46 feet. Who did the research analysis? Who did the risk analysis? Coming back to Lotus Riverside apartment, that also collapsed because the complex was built next to a river. Now, when I'm giving you so many examples, what happened in the World Trading Center? You all know about it when the 9/11, when the terrorist jets, they hit the building. At least 1,000 people could have been rescued. It is just because of the faulty design. 1,000 people lost their life. What happened in the design? The staircase, the narrow staircase, the staircase was built very narrow. While the firemen were trying to go up, they were trying to go up. There was no place for the people to come down because lifts don't work. So you can just see what I'm trying to say is all these causes, this could have been foreseen as a risk, but they did not do that. Now everything is history now. The damage has been huge. Recently, a few days back, in this week, in Maharashtra, there's a collapse of the building. The building collapsed. The building was not officially on the list of danger. It was not declared as a dangerous or a risk-prone building. Now, Albert, you can see this. The building was not officially on the list of dangerous structures within the limits of the Bhiwandi Nizampur Municipal Corporation. Why has this happened? I would like to share some of the pictures of the buildings which collapsed. You see this, the Trade Hall, Poland, World Trade Center. This is another which recently we have seen. Relatives here, if you see, is all because of poor construction. In Jammu, a concrete bridge. How can it happen? It was just built a couple of years back, 5-6 years back. What happened? What happened to your quality assurance? We have got a good syllabus. We have got top engineering colleges. We learned a lot of civil engineering techniques. We learned, we get gold medals. But what happens when these kind of incidents happen? I was just telling about the World Trade Center. After the jets hit, stairwells became the sole means of escape for thousands of occupants, but erratic design choices. They did a root cause and they found out this was the reason. Had they made the staircase a little wider, as per the design, we could have saved at least 1,000 people. This is the departmental stores in South Korea. It's all poor construction, nothing else. Now, let us look at we are talking about how to evaluate the risk. The risk analysis can be done by using a FMEA chart. The template is right in front of you. Very simple. I will explain to you, and if I am given an opportunity to conduct a workshop, you will understand it much better. If you look at the template, is the process function. There's a company which manufactures packing materials. This can be conceptualized in civil engineering also. There's a pasting and opening. This is the function, and the potential failure mode is suddenly the pasting may open up because of lack of inadequate glue. And what is the impact? The cottons, they open up, and the entire box gives away. The material inside the carton, it 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 is thrown open. The severity is very high. It is around 9. And if you look at the potential causes, what are the causes behind it? The glue level in the tank is depleted. Glue wheel is not touching the glue level, so it is not applying the glue. And that is the reason. An occurrence, many times it has happened. If you look at it, it is 9 on a scale of 1 to 10. Severity is very high. If a box open and the material which is kept inside will certainly fall. If it's a fragile material, it will break. So you cannot expect a box to break. So the severity is very high. The pasting and opening severity is very high. The occurrences are also, many times it has occurred. And the detection controls, or they do manually. A person has to check whether it has pasted properly or not. How can he check? Not possible. He cannot tear every box and see whether it is properly pasted or not. And if you look at it, as I said, a severity multiplied by occurrence into the detection controls, it comes to 810. 810 is the risk priority number. You cannot, it's a total disaster. A company will reject the packing cartons and they will never purchase cartons from the supplier if it doesn't take immediate action. So what they do, if you look at it, they have installed a sensor. Please look at this table. It's very important. I will tell you with actual examples also. This is a small example to make you understand. They've installed a sensor. When they've installed a sensor, the severity will not change. The severity of carton opening will always remain the same. That's why I've shown as 9. But the occurrences have come down. They put a sensor, and whenever there is less glue, the sensor will immediately sense it and it will stop it. It will throw such cartons which are not pasted properly, where it will discard the cartons in which the glue has not been applied, in which the glue has been inadequately applied. It will throw out such cartons. So what happens is the occurrences have come down and the detection controls are now stronger. Earlier it was man-based, manually, and now it is done by a sensor. So if you look at if we multiply the severity multiplied by the occurrences and the detection controls, comes to 36. What a fall from 810 to 36. But 36, Japan will not allow that unless you get a 0 defect. So how to bring it still lower? You go fix a sensor. But how do you know whether the sensor is working or not? So you need to put some you need to test with the test pieces. You need to see whether the sensors are really validated, whether they are really serving the intended purpose or not. So what they do, they did some test pieces. They put some, as you know, we have got a system to see whether the sensor is working. So what they did, they used to pass some test pieces with the inadequately applied glue and all, and trying to find out whether the sensor is really working. After that, as I said, the severity will not change, but occurrences came to 0. And detection controls were top, because you are not only installing the sensors, but you are also validating the sensors and checking them whether they are serving the intended purpose. So it comes to 0. So all I'm trying to say, there are a lot of beautiful methods to ensure that nothing goes wrong, no failures. Why not we learn all that? So failure mode, I've already explained, it's a tool to identify, quantify, prioritize the risk within a process before constructing, building, and then track actions to mitigate the risk. Now, having said all that, just let me spend a minute on what is Six Sigma. Six Sigma, getting a master black belt. If you all, with all your very valuable BE and ME degrees in civil engineering, if you learn about Six Sigma, your value is appreciated 100 times. Why 100 times? 1,000 times. If you say, I'm a BE or an ME with a Six Sigma black belt, you see how much your value gets appreciated. See, I don't say your BTech or BE or ME, they're valuable. They are basics. They are basics. It's a must. But then this will keep you on the launching pad. You are sitting in a rocket to go up. You go into the space. So that is the kind of And what is there in Six Sigma? Six Sigma helps you in problem solving. The efficiency is 99.999%. And if a company is working on a Six Sigma philosophy, it permits only 3.4 defects per million opportunities. If we have done million activities, there could be only 3.4 defects. That's it. Now, we are talking about Lean Sigma. Lean Sigma is also very valuable. Just like Six Sigma, there's a Lean Sigma, which simply reduces the cost of production, cost of manufacturing. It reduces the waste. So that what happens? You are able to give a better product economically to the customer. There won't be any wastage. The company will be able to manufacture the product without any non-value addition, without any wastage, without producing any defects. That is the beauty of Lean Sigma. Then comes your Poka-Yoke. Poka-Yoke, it is just a method which will not allow you to commit any mistake. Even if you want to commit a mistake, it will stop. For example, the car will not start unless you put the seat belt. At least now it gives an alarm. In some of the cars, in Japanese cars, they will not start. If you put an ignition, if you put the, it will not start at all. It will show a beep light telling that put on your seat belt. So why not we think of such applications in our construction projects? So I have already explained about the FMEA part of it. So in a construction safety management, the process of construction activities, how to do the FMEA is very simple. You first list down all the activities from A to Z, from foundation till the end. You list down all the activities. In one foundation itself, they did a brainstorming, a team, and they found 181 activities are there in the brainstorming. Actually, 180 steps are there in the foundation itself, including the sub steps. List them all. Work on the severity, what impact it will have on the finished building. Work and also find out the possible occurrence. If there is a failure in this particular activity, what is the possibility of the failures to occur? And also list out how strong are your detection controls? Is it manual or is it left to good luck? Or have you got a system? If your foundation is crumbling, it is giving a small shake up, and there's are you getting some signals? Have you got a small device which will find out there is something going wrong in the foundation? Even after 25, 30 years, even after 50 years, the building has been erected. You should have a system to give a beep sound. Yes, the construction, the strength of the construction, the foundation is getting weaker and there are cracks developing. So all this is nothing but you are foreseeing the risk and putting the preventive measures in place. We can work on it. I promise you, in a small workshop, whenever the pandemic situation eases out, I'm sure I'll help you out. Now, this is also a failure mode, a template. Here, if you just have a look at it, to explain you, the process function is a drill blind hole. I'll give this presentation to Professor Gokul so that it will be a kind of a informative subject to all of you. It will be very helpful in planning out quality concepts and all that. Now, if you see here, it's a drill blind hole. You can see this. And the potential failure mode is either the hole is too deep or it is superficial. And the severity is also there. If you look at it, the occurrence also has been mentioned, and the occurrences also have been mentioned. In the first case, the risk priority number is 63, and the next one it is 45. And after that, the broken drill, the potential causes of the possibility of a broken drill, uh, it comes out because you don't have any detection controls, the risk is 225. Now, what do we do? This is done even before the project starts, and they will work out on this particular failure mode and ensure that this 225 is reduced below 50. This is the objective of failure mode effect analysis, and keep on reducing the risk till it comes to zero. But a good risk level is, if it's below 50, the whole world accepts it. There's not much of danger if the risk number it comes below 50. Now, this is just a template. I have not wasted. So this I have already told. The severity into occurrence is equal to criticality. The severity into occurrence into detection it gives the risk priority number. I've already explained the failure mode effect analysis. If you look at it, the 1 minute. The highest risk is 1000 RPM. The highest risk, if your FMEA, failure mode effect analysis, shows 1000, that means there's a disaster. You have to immediately attack on it. And above 500, there's a very high risk. The moderate risk is around 250 to 300, and the low risk is 40, and zero defect is no risk at all. The spaceship can take off. Normally for rockets and all, they go for a zero defect. Only unless there is a zero defect, zero is the risk, only then the countdown starts. This is another FMEA I've done with concrete mix for roofing. This is little bit relevant example for the civil engineering. So the potential failure mode is improper mixing of cement with sand. This is the potential. The mixing may not be proper. It may be non-uniform, improper. So it may, what is the effect? What is the impact? The potential threat is resulting in a crack. Water seepage may happen, and then the water may seep in, and the rods may get rusted and corroded, and the entire building may start leaking, and in a while it may get collapsed also. The severity I have written is, we have mentioned, is 8, and the possible occurrences are also quite average. They keep on happening, and detection controls are manual. You can't do anything. You don't have a system. You don't have a kind of a device which will say that your concrete mix, your mixing has not happened properly. No device, no. You just mix it and just apply it. Then the action taken to mitigate, they conducted testing of the mix, concrete mix, ensure proper mixing with right proportion of ingredients, make a sample mold and test for the hardness, water permeability, and all that. You all know about it. I don't have to explain all that. So when they did that, the severity will not change. As I said, severity will not change at all. So the severity continues to remain at 8, but your detection levels have improved. Therefore, the risk level has come down to 1. The risk level was very high, to 5, because you have checked it by simulating a mold. You have made a sample piece before you transferred the concrete mix. So your detection controls, you worked on it to ensure that this will not give away. The mix will be perfect as per the plan. And the occurrences have also come down. The risk from 200 has come down to 8. You can proceed with confidence. This is all the thumb rule I've already explained, because the time is a factor. So as I said, these are all the severity, very low, moderate. This is a rating on a scale of 1 to 10. If your severity is very low, you could give a number of 1. If the moderate, give a number of 5. If the severity is very high, you can give 10. Occurrence, same thing, very low, moderate, and high. If it's high, you give 10. If it's very low, give 1. Detection level, again, if the risk is low, your detections are strong, and risk is low, you give 1. If the detections, you don't have a proper detection level, it is only by manual, then you can give, the risk is high, so it becomes 10. So this is the rating. I also, as I said earlier, the success of Mangalyaan satellite is due to the extensive FMEs carried out before the launch. The root cause for any problem is always in the 5 M's. Any cause for any disaster is because of 5 M's. One is material. It is material related, or method related, or machine related, or man related, or mother nature related. So you need to have a complete plan. You need to think about all these 5 M's, because these are the 5 M's which contribute to failures. As man related, material related, method related, machine related, or mother nature. Now, why good construction practices? I don't have to spend much time. You are masters in this. You have got very good professors and a beautiful institution to teach all that. But still, I'll go through the best construction practices. Investigate the soil, determine the structure design, check the concrete mix, inspect the wall thickness, ensure safety features, look for paint and plastering quality, examine the elevators. These are the good construction objectives to prevent or eliminate error at each stage of construction. I'm only talking about failures. We have done a lot of good constructions and they have collapsed also. Now there's a small shift. We are trying to change our thought process. You need to prevent and eliminate an error by foreseeing the risk. So identify the possible risk and potential threat on the constructed building bridge to take all necessary precautions to ensure that we construct buildings of the required high quality and safety, to reduce disorder in the system of construction, to show concern for the constructed building and the people, develop leadership qualities with an attitude for quality. Whenever you do a brainstorming, you should have the person who is even a labor, right from the labor to the the top project head. All of them should be there to do a brainstorming. We don't know. You may get a golden idea from the man who is carrying the bricks. International standards. These are international standards. The American Society of Testing and Materials. I hope you're aware of this. Euro codes 15, BS codes. These codes describe details of standard methods of testing, procedures, and methods of concrete masonry. But all this is fine. You need to find out. You don't want the best material. You want an appropriate material for the intended purpose. I don't need the best material, the world best material. I only need material which will serve my purpose, where the buildings can be safe and it will stand for the number of years what you have planned. So some of the standards: ASTM, Canadian standards, European standards, British standards, Indian standards. Now all these standards are going for risk evaluation. Please understand, all these standards, they want risk evaluation to be done. That is the reason why I'm focusing on this. Building construction, step-by-step process. What can go wrong? Evaluate the risk. Building construction project, purpose of construction, utility, financial proficiency, the demand for work, planning. What can go wrong? You need to apply your quality assurance and risk evaluation. They check cement, best for house construction. You are not the best of quality, best of the grade, or from a very good manufacturing company. You need to check whether it is the best for the house construction. For calculations, you all know about it. You are civil engineers. The total load on the columns, beam, slab, we must know about various load coming on the column. You need to verify. Generally, column, beam, and slab arrangement is seen in the frame type of structures. Load is transferred slab to beam, beam to column, and ultimately reaching the foundation of the building. All that I need not say, because I know you learn all that from your gurus, from your books, from your beautiful syllabus. We have got a beautiful engineering college here, and our syllabus is one of the best in the world. Only thing is, they need to be little quality focused. That is my request. So, quantify the risk level and all that I have already discussed. We are quickly going ahead. Now, this is which is the most appropriate cement for the house construction. For your type of house construction, depending upon your locality where the house is going to be constructed. Not the best, but what is appropriate. OPC 43 grade cement, it might be the best, but whether it is serving your purpose, you need to prove it. You need to verify before you use that. Or it is a OPC instant plugging mortars. You all know about the characteristics that they are fast-paced construction in which the initial strength to be achieved very quickly. Validate it, no. You need to make a sample really whether it is the initial strength is achieved where you want to, whether it is really serving the initial strength is achieving very quickly. You need to verify and validate before you use materials like this. And if you don't verify, you will face disaster. The same thing with this. Portland slag cement, same thing. Excellent corrosion resistance might be. Do it. Find out whether it really serving the purpose. Who knows? The slag cement what you're going to get may not have all these characteristics. Make a sample, test it, ensure that it has got the right kind of characteristics before you use it to avoid failures. No failures. No failures. If at all you feel there is a failure, cut open and find out where the failure can happen and take preventive measures. Don't leave it just like that. The same thing with white cement. Why it is important to manage construction risk? Labor issues may crop up, labor shortage, labor productivity, labor quality, safety hazards, coordination hurdles, poor documentation, inconsistent reporting and errors, the controlled construction risk using software, all these things. Where you should evaluate the risk. Suppose you have got some set of labor and they stop coming. Will you start will you stop construction? Will you get a new labor? Who knows whether they'll work to your satisfaction or not? My dear friends, everywhere you have to foresee the risk. If you don't foresee the risk and you keep on working mechanically, the result is going to be very dangerous. It's going to be a disaster. What can go wrong? The 8 steps. The soil testing can go wrong, and report analysis, demolition of old structures, underground service and wire mapping, site survey and layout, site clearing, site excavation and earthwork, compaction and construction. Think for a while, call for a brainstorming, call all the people and just try to analyze and foresee what risk we could face in soil testing and report analysis, or while demolition of the old structure. You are the right person. You need to think about it and take preventive measures. Soil testing and report analysis, analyze what can go wrong. What can go wrong? What went wrong? Don't do that. It's a sheer waste. If you start talking about what went wrong, it is just like doing a postmortem. The soil testing is essential before planning and designs any construction project. Without knowing the properties of the soil, we cannot design any structure. Soil geotechnical investing is carried out. You need to find out what is the risk. If you feel that there is no risk, go ahead. Demolition of old structure, what can happen? What can go wrong? The demolition of old structure is important in construction site preparation work. Old structure, prepare a plan to demolish it with the help of a demolition team. Demolition must include which structure on the site needs to be demolished. Structures on site which requires repairs or not demolition, you need to differentiate. Systematic planning, identify hazards, ensure safe disposal of materials, comply with the legislation requirements. Your building is half done, and there might be a roadblock by the legislation committee. You need to be very careful. You need to you should not take any risk in that aspect. Site surveying and layout, the same thing. Engineering surveys will ensure that the building structure is built in the proper place as designed to obtain data concerning topography, drainage, man-made features and all that. Evaluate earthquake prone, possibility of flood, seawater, corrosion. You're building you're planning to construct a building near a river. I don't say don't do that, but then plan for it. Foresee the risk and use the appropriate material for that kind of project. Validate it and use it. The site clearing, same thing. Something might go wrong. So you have to removing any underground wood, underbrush, trees, rocks to distance. All this is very important. And this does not need any standard, does not need a BE or ME degree and all, or a doctorate degree for it. It's all brainstorming. Call all the people, sit together and brainstorm at what can go wrong and foresee the risk and take action. Do a brainstorming. Site excavation and earthwork, same thing. Distance the soil. You are the best man. We don't know what can happen. Call the people, call the nearby surrounding people and think, apply, not one man. When 25, 30 people all sit together and brainstorm, I'm sure the result would be excellent. So we have seen in case of hard soil like rock is available on construction site, blasting, drilling and machineries like boulders, backhoe, shovels and scooper are involved to excavate and transported blasted and drilled materials when rocks are present at the site. This is the compaction. Here also we need to take appropriate preventive measures and foresee the risk. You all know about. I don't have to say much about the compaction of construction project site and all that. Anti-termite treatment, you all know about it. This could be a total disaster if you don't do the treatment properly. Even before you start the project, you need to completely determite the soil also. How to reduce pollution at the construction site? Again, adhere to the security norms and avoid dumping of the material. You all know about it, but then try to foresee what I'm saying. All I'm trying to say is you don't ignore all this. Training. Now, this is, if I see some of the very good reputed construction companies, what they do in the morning, they will all wear their helmets and there'll be a group meeting. If you look at, you might have seen, they'll wear all helmets and all that. All of them will go and stand in front of the supervisor, and the supervisor will give them a briefing. The training is very important. A trained civil engineer on FMEA. Suppose you learn FMEA, you learn the preventive measures in your college level, and when you become the project engineer, you will certainly ensure that all these things are practiced. Quality assurance and best construction practices, risk analysis is done. Now, design, construction and installation. All new buildings and equipment should be designed to comply with the best construction procedures. And best construction procedures is not taught in colleges or available in any standard. It is a passion and dedication that is collectively evolved through experience, skill, validation, simulation, and evaluating the failures even before starting the construction work. These are the standards, the contract documents, the written procedures. You need to have, for consistency, you build a beautiful project, you work out and plan a beautiful project, it comes out very well. You should be able to reproduce, because many people on seeing your monument, the constructed monument, they'll say, why don't you make something similar like this at our place? You should be able to reproduce that. How will you reproduce when you don't have written procedures? You get consistency when everything is written and converted into a specification, a standard operational procedure. The validation, of course, what is validation? It is just to find out whether it is serving your intended purpose. How to do validation? Do by simulation. You make a sample mold or you verify it, but validation has to be done. Without validation, you cannot go to the next step. You can, if at all there is a risk, only validation will eliminate the risk. Housekeeping, pest control is very important. Now, there is a housekeeping called 5S. It's very important, and there is a separate course for it. It just an hour will take, but then this is very important. You go to any industry, any service industry or a manufacturing industry or a construction industry, these 5 steps are very important. That is sorting out, setting in order, shine, standardize, and sustain. This is the order of the day. The whole world follows the 5S principles. Then the 5 construction principles are these: the environmental protection, safety, speed, economy, aesthetics, the quality assurance of construction materials. I've already told about it. The quality assurance of construction materials in continuation, the testing and inspection at the receiving end, proper storage of warehouse. All this is risk oriented. You need to store in the warehouse, store to avoid deterioration or damage during your storage, and conveying the quality specifications well in advance to avoid stockpiling or getting rejected or mixed up. So all these steps used appropriately help to ensure the right quality of the incoming construction materials, which ultimately reflects in the final product of the project. Storage handling, same thing. Poor storage of timber, cracks, effect of improper storage. Can't believe you will develop cracks, cakes, spilling of the concrete from corners and edge of the concrete, deterioration in quality, reduction of strength of concrete, unsmoothness, poor storage of timber, free from pests, poor storage of bricks, away from water. All this have to be worked out. All this is very important if you want to make safe, if you want to construct a building in a safe manner. These are the construction failures. I want these construction failures to share with you. I'm only talking, I don't talk about the good things. The construction failures are structural failures occurring during the course of construction, partial or total collapse of structure, excessive deformations, cracks, misalignments, failures caused by concrete as a construction material, chemical composition of the cement, grading of the cement, quality of water, the mixing of method and quality, proper placing, finishing of the concrete, proper curing conditions. So all these could result in failures. Have you worked out? Have you foreseen all that? We are talking only about, my entire presentation is on that. These are the factors affecting the concrete. You all know about it. But these are the factors. The concrete being subjected to repeated cycles of freezing and thawing, the concrete component subjected to extensive shrinkage, the chemical attack of chlorides and sulfates, the presence of high content of alumina. So all this, you are aware of it. But evaluate the risk when you start a project. Not after the construction or during the construction. Work out. These are the things which can happen. So have you taken adequate preventive measures to avoid these failures? There's failures caused by masonry as a construction material. You all know about it. I don't have to teach all. This is a part of your syllabus and you are masters in this. But then you need to foresee that. Cracking during a settlement issue, shrinkage and bending process, the thermal expansion of masonry units, the wall that is running in the same direction may undergo shortening, lack of proper consideration of design and detailing of the expansion and the controlling point. All this is a part of that. We are talking about wood, the failures in wood, moisture content, density, splits, shakes, density, knots, checks. We have seen in one of the failures happened because of poor quality of wood. So train the construction team to do a foolproof risk evaluation for the respect. When you are yourself trained in this field, you will always foresee the risk. That is the reason why I was requesting your Professor Gokul sir also to conduct a small workshop. It will be very useful to you when you pass out and join the construction industry or open your own construction project, your own private construction business. Quality has to be assured before the construction starts. Now, what are the 5 R's? Robust specifications. You should have robust specifications. Relentless training and supervision. Never ignore the training part of it. One man who doesn't know the job, if he does the wrong thing, you are finished. The whole thing goes haywire. So relentless training and supervision, risk evaluation, ruthless surprise audits. That is why the Indian civil engineers are valued. They are always there on the site. I have not heard any civil engineer sitting in an AC room and enjoying. He's always there, whether it may it be raining or may it be snowing or may it be scorching hot, but still you will find our civil engineers standing over there. The RERA is another very important regulatory compliance. Thank you. Thank you, sir.
Yes, sir. See, sir, it's seriously an awesome presentation, sir. Actually, participants kindly know that sir is having nowhere contact with the civil department anywhere. Okay, he prepared by his own separately. He took around 3 weeks of time and he prepared completely about civil engineering, what all the things are there related to quality assurance and what are the problems normally occurring in civil department. Everything he analyzed it by his own and everything he done perfect. So seriously, I didn't expect you will give this much of elaborate explanation in civil department. So really, it's an awesome presentation. Thank you so much, sir. Thanks a lot, and thanks for the participants who participated in our whole 1.5 hours. Sir, some 2-3 questions are there. Can I ask, sir?
Certainly, sir. Most welcome, sir. Most welcome, sir.
Yeah, just. What is the key role of quality control engineer?
Come again, sir. Please come again. What is
the key role of a quality control engineer?
Right. Very, very nice question. Quality control, as the name itself indicates, it is a reactive process. What quality control people control means you are controlling during the receiving of the building raw materials or during the construction process. Their job is very limited. They will only ensure that the materials what you are using are tested, and they are within the specifications. If they are not within the specifications or as per your required, as per the required quality, they will reject it and go home. They will not do beyond that. Their job is very limited. During the construction process, they will say, no, there is a distance, there is a variation in the height, the bricks have not been placed properly, and they will go away. So it is a reaction, just reaction process, that the quality control people they do a reactive approach. Nothing, they don't do any proactive approach. They don't foresee the risk. They don't have any such business at all. That is the reason the quality control people are required. They are there for a short gap arrangement, but their involvement in the assuring the quality of the project, in assuring the safe, the safety of the monument, safety of the building, or the tenacity of the building is not done by them. They will not be in a position. Quality control persons will not be able to assure that the building was it is constructed will be there for 10 years, and come what may, even when the dam breaks open, nothing will happen to the building. That kind of assurance you will not get from the quality control engineers. They are only reactive. So again, to answer your question, Japan has eliminated the quality control approach. Why not you call them quality assurance? You do quality control, but then you integrate it with quality assurance. Instead of saying what went wrong, you always say what can go wrong and work on it. That is my reply. Is it okay, sir?
Yes, sir. Exactly.
Yeah.
Sir.
Another. Yes. Any more questions?
Yeah. Another one question, sir, from Krishna Mohan Reddy.
Yeah.
What quality assurance and quality control activities are done differently for a project, sir, for project development of a projects?
Wonderful, sir. Very good question. Quality assurance has got no role after the building is constructed. They don't do any work. All their work is done at the project stage. The quality assurance man, he will call all the planners, he will call all his people, all his technical experts, sit with them, and he will discuss the plan. He will open the plan and tell them, look here, we are going to construct this project. And in the construction of this project, stage by stage, they will list down all the activities. It's a very ardent job. It's a tough job. Every stage they will discuss, and they will try to find out in that stage which step is the most severe one, which has got the highest severity, and which has got a direct impact on the construction of the final in the construction of the building. They will find out two things. One is the severity of that step. That step in foundation, as I said, when they did a brainstorming, 181 steps came out in foundation. So each step you need to find out what is the severity, whether it is high, medium, or low. Low, you forget about it. If the severity is high and it has got a direct impact, work on it. Why it is having, find the root cause and try to find a solution. Only then proceed further. So quality assurance is it's the way of life, sir. You cannot think about quality control, cannot even come near this. Quality assurance, in fact, will allot the work to quality control. They will say, quality control man, ensure that the building is done. You have seen in my presentation, there was a QMS table, quality monitoring system, where is inspection point, parameters for inspection, all that will be given. They need to record that. The quality control engineers will record in the quality monitoring system at every stage, and you keep that as a record.